Not a ton, no. You can watch the lesson on my YouTube channel, Mr. McCoy, BKW Chemistry.
I watched it last night.
If pressure increase on an you probably slept like a baby. If pressure increase on an equilibrium, it will shift towards the lower number of moles, and then the opposite. If pressure is decreased on an equilibrium, it will shift. And again, writing this doesn't really do a whole lot, but I just wanted to get it down. The practice problems is what helps you learn it. If pressure is decreased on equilibrium, it will shift towards the higher number of moles. Yes, you can. So, there is a video I'm going to show you quickly. But I think what I'll do is explain it first, because we're running out of time real fast. And your homework, I want to make sure you're able to do it. So it's only going to take me a couple minutes to give you an example of temperature, and then I'll end with the video. If you get chopped off, we'll just show it again Monday. So here we go. Temperature is a different story. So let's write this down. Temperature. So temp changes for equilibrium. Temp changes. I'm just going to give you an example. You have N2 plus H2 yields 2NH3. This is a gas. Let's see, that's 3. Gas, gas. And it's positive 91.8 kilojoules. They're not positive, but we're adding 91.8 kilojoules over there. This is at equilibrium. Is this exothermic or endothermic? Exothermic. So the potential, don't write this, but the potential energy curve will look like that. It would have less energy as products, more energy as it loses it as it goes forward. What about the reverse? What if we're going that way? Is it still exothermic?
No.
No, it's endo. Jeffers, why is it endothermic going this way?
Because it ends with more of this.
Good. It gains heat, so it ends with more energy. Ends with more, so it's gaining heat. So when you see a reversible reaction, equilibrium, whatever it's doing one way, it's the exact opposite the other. Okay? So it's exo going that way. That means you have to go back up the mountain. Endothermic going to the left. So why is that important? Here's why. Write this down. If the temperature increases on this reaction, the equilibrium will shift towards
There's an O in towards. TW.
it's towards.
Towards. Okay, then I've been spelling it wrong.
Towards.
Every time I wrote.
Well, I'm glad I can help you with something else besides chemistry. Chemistry.
Yeah.
All right, now, here's how I teach this. The video's a little different, but here's how I teach it. Imagine that this 91.8 and temperature are the same thing. So when I say I increase the temperature, what I really mean is I'm increasing that number. Not a good way to teach it, but it's also a really good way to teach it. The reason it's not a good thing is because temperature doesn't exist. Temperature is a scale we made up. Heat exists. Temperature measures it. So temperature isn't a thing. But the way I teach this is to treat it like it's a thing that I can put on my balance beam or my seesaw. So imagine temperature is a thing, and we're adding it to the heat that's already there. So if we increase that number, okay, let's use my arm here. If we increase that 91.8, does my elbow go down or does my hand go down? If we add more to this side of the balance beam, right? So we're adding more to this side, but use my arm as an example. My hand's going down, right? Because it's going to be heavier because I added more to this, because I increased temp, right? Everybody with me?
Yes.
how does it have to shift to go back to being balanced? Shifts to the left. So it shifts towards the reactants. So the rule with temperature is if you heat up a reaction at equilibrium, it always shifts away from the energy. It always shifts away from the energy. Where's the energy? There it is. So if you heat it up, it's going to go this way. If I had the heat on this side, it would shift away from it. Alright? But I don't. It's on the right. So the other thing I want to say here, because I am going to run out of time, write this down. If the temperature is decreased, then the equilibrium, that's really messy. Equilibrium will shift to the right. So, again, if I treat temperature like it's an actual substance, which is bad to do as far as the theory, the material you have to learn, it's not good. But I think it helps students understand, if you reduce that number, you take that number down. If I take some weights off of this, what's going to happen to this side? If I take some weights off of that side, what's going to happen to it? It's going to go up, right? So we're balanced. If I decrease the temperature, I'm lowering that number to, let's say, 50. It's going to go up. It's too light. It doesn't want to be 50. It wants to be 91.8. So what has to happen? We shift this direction to bring it back down. So when you decrease temp, the rule is it shifts towards the energy. So when you increase temp, it shifts away from the heat. If you decrease temp, it shifts towards the heat. So that's how I teach it. I did it kind of quick with you guys. Try and do the worksheet because we're going to run. The bell's going to ring, so we're going to have to stop. Try and do those worksheets, all right, for Monday. And have a good weekend. We'll go over that again on Monday.
It's chapter 4, you say?
Chapter 4 review book, yeah.
Alright.